Hey, this is Jen, and you really do love science. You just don't know it yet. So, just like any other problem in physics, once you've listed all of your givens, you've listed everything you know, then you look for the equation that matches those givens so that you can plug some numbers in and solve the problem. So what normally happens is you look at all these equations and you look at all your givens, and most students, and even I do this, they start out by saying, well, here is a horizontal equation, and this one looks nice and easy. So let's see if we can just go ahead and solve this one. Let's see, horizontally we know our velocity at least. So I'm going to go down here and I'm going to say, okay, velocity is distance over time. That's my horizontal equation. So I'm going to say the velocity is like, okay, 600 meters per second. The distance horizontally, we don't know that. As a matter of fact, that's what we're looking for. Okay, so we don't know distance, no big deal. We'll put a D there. That's what our goal is for this problem. And then you go time. Okay, where's the time? Did they give us the time? And time in most of these problems is exactly what's missing. And I'm going to tell you now why it unlocks the problem. You notice how we separated all of the vertical information from the horizontal information, because the vertical distance that the package falls is not necessarily the same as the horizontal distance that the package falls. And the vertical velocity of the package as it's falling with acceleration due to gravity is not going to be the same as the velocity of the plane flying horizontally. So all of these things horizontally and vertically are different. But guess what? The time is not different. Oh, I just got chills. The time is not different because, think about it, when the package stops falling vertically, it also stops falling horizontally. Let's just assume that it hits the ground and it doesn't roll. So when it stops falling, it stops falling. So the time is the only thing that's the same on both sides of this chart. That's why time unlocks the problem, because time is the quantity that allows you to jump from one side of this table with horizontal and vertical to the other side, because time is the only thing they have in common. So I'm going to write down here, if I can fit it, I'm going to do like a box here. Yay! I'm going to get rid of that little D for just a second. It's kind of in the way. And then I'm going to say, okay, if time unlocks the problem, then we can just say time equals, and we'll say, you know what? It's going to be the same for vertical and horizontal. So if we could just find time, either horizontally or vertically, since they're the same, then bam, we could use this equation right here, and we could get our horizontal distance, which is what the teacher asked for, and we'd be done. Too bad, horizontally, we do not have enough information to get time. Because look, we ran out of information horizontally. We've exhausted everything we know. So that's why we have to go to the vertical information. The vertical information is what's going to give us time. And also, too bad that I ran out of room on this screen. Some people have said my logo is way too big and I should shrink it down, which I'm sure I will do later. But for right now, I wonder, I don't want to really erase my time key, you know, because it's such a beautiful drawing, but for the sake of space, goodbye time key. So sad. There, the time key is gone. But remember in your mind, please, the picture of the time key. Never forget the picture of the time key. Keep it in your heart always. Okay, so now we have to jump to the vertical side of this chart or table, whatever. It's not a chart, it's a table. Jen, come on. And we're going to go over to these equations on the left side of the page, which are vertical equations. So let's go for it. Which one do we use? Okay, don't feel scared. I want you to look at them, and I want you to look back at our given information right here. And I want you to say, okay, well, which equation can I use? Remember that you can't have two unknowns if you only use one equation. Later in the year, we'll have two unknowns and two equations, and we can combine the equations, and that'll be cool. But right now, we're just going to pick one equation where we have one unknown and solve for that. Remember that the thing that unlocks this problem is time. So let's try to choose an equation that's got time in it, so at least we can find time. I mean, if time's the key that unlocks the problem, then why are we choosing an equation that doesn't have time? So let's look. The first one has time. All right, let's check it out. Yes, it has time. We do want to solve for time. We do know acceleration. I'm going to put like a check mark right here because we do know acceleration. That's negative 9.81. We do know the initial velocity. That's 0. We're getting good. We're getting close. We're feeling good. Uh-oh. We don't know the vertical final velocity. Remember, once we start plugging in vertical information, everything in the equation has got to remain vertical information. Do not mix horizontal information and vertical information in the same equation. The one exception is time. All right, so why did I check vertical final velocity? I did not mean to check that because it is an unknown. We can't use this equation. We have to try another one. Let's go to the second equation. Okay, we already see that we don't know vertical final velocity, so I'm not going to pick that one. And also, there's no time in this equation. We could find, we do know the distance. We could find the vertical final velocity using this equation because we know acceleration, we know the vertical distance, and we know the initial velocity, which is 0 vertically. So we could use this equation to find. So you would use this if the teacher asked, I don't want to write it because I need the space. If the teacher asked for the final vertical velocity, then you would use that equation. Ooh, look at the third equation. Do we know a vertical distance? Yes, check mark on that. Do we know the initial velocity vertically? Yes, check on that one. Do we know the acceleration? Yes, check on that one. Yay! This equation has only one unknown, which means we can use it. All right, let's do it. I'm going to go delta D equals VIT plus 1/2 AT squared. I'm starting to feel good. I'm starting to feel like I'm going to find the answer. Delta D vertically, 400 meters. All right, quick, you go 400 meters. Yay, I'm feeling really good. And then your brain stops you and says, hey, wait, don't go any further. The package was falling down. Remember, the package was falling down. And then you go, oh yeah, it was falling down. Check it out. Negative 400. Thank you very much. If you don't do that, you'll get the wrong answer. Okay, so negative 400 meters. I'll do the negative in the same color. Equals initial vertical velocity. What was that again? 600? Oh, nope, not 600. That's horizontal. Oh, the initial vertical velocity was 0 because as soon as the package was released, it was only flying horizontally. So vertically, okay, so we got 0 for that. And 0 times time is 0, so we'll just leave that as 0. 1/2, we're getting there now. Remember, negative 9.81. And look, there's only one unknown, and that's going to help us solve the equation. So grab your calculator, and let's plug these things in. Well, we still have negative 400. I know you know how to do algebra, but just in case somebody's struggling, I'm just going to plug these things in. So it's going to be like negative 4.9 t squared. Oh shoot, it's like, if I have 9.81, it's not exactly 4.9. I usually work with 9.8, 4.905. Thank you very much. I'll just leave it as 4.9. All right, negative 400 equals negative 4.9 t squared. Do like negative 400 divided by negative 4.9. Good, the time's going to end up being positive. Thank you very much. 81.63 equals t squared. Don't forget that the t is still squared. We're going to take the square root of that baby. 9 point, seems like we have it. Feels like we have an answer because we solved something that took a long time. 9.04 seconds. Oh, you know what? Check out my given information. Look at the airplane. How many significant figures did I give you? This is what I always do. It's like after I solve the problem, I'm always telling my students, oh, by the way, sorry, I meant to give you like more than one significant figure. So I put a decimal there. and I put a decimal here, it's like, haha, forgot to give you more than one significant digit. So there we go with 3 significant digits with that decimal point showing. So the t that we just solved for, if I can get that color back, the t that we just, would you call that magenta? I would call that magenta. At least on my computer it's showing up as magenta. And a raspberry. I think it's raspberry. So t equals 9.04 seconds. That's the time. Here we go. I'm circling it. I feel like I'm so done with this problem because I worked so hard. I did a long equation. I plugged in a heck of a lot of numbers and I used my calculator and it feels like I'm done, so I circled it and I want to go on to the next problem. But are we done? We're not done. Did the teacher ask for the time? No, the teacher did not ask for the time. The teacher asked for what? The horizontal distance. Oh, we are not done. On every problem, of course, I want you to check back to make sure you answered the question that she asked or he asked. We're not done yet, but at least we have this great feeling that we can go to our pretty little table and we can go da 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 da, we have the key to the problem. Da 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 da. I'll give it a smiley since I have room. 9.04 seconds is the time it took for this thing to fall, and that's the same horizontally as it is vertically. Yay! Okay, now guess what? Now I think we might have enough information to solve with the horizontal equation. Let's go green. Let's go green. There's our horizontal equation. And by the way, once again, this is your only horizontal equation. Horizontal side is so easy. It's like the vertical looks at the horizontal and goes, you are so lame because you're so simple. And the vertical is like, I am so sophisticated and complicated. Look at all of my equations. I mean, you can't even compare to my equations. And the horizontal goes, yeah, dude, but life is simple, dude. Get a grip. So what we're going to do now is we're going to take the simple horizontal dude and we are going to go down here to, all right, look at my logo. I'm going right above my logo right now. The huge logo that I should shrink. All right, so now we're going to go V, which we know horizontally is, oops, that's a little too low. Excusez-moi. V is 600. The distance is what we don't know. Thank you very much. It's still a variable. And the time we do know, 9.04 seconds. Yay, we can solve it even though we don't have room. So I'm going to do 9.04 times 600. Man, oh my gosh, it's going in the river. Shoot. The food and medicine is landing in the river. It's 5,421 meters. These guys are going to have to walk a long way to get this package. Sorry, guys. So I only have one little spot of room on this page right now. What color should I use? I'm not really a fan of purple. I don't think you're going to see a lot of purple on these whiteboards. What about, let me try a crazy bright orange, which I think actually turns out to be a weird orange, but we'll try it. All right, so the distance horizontally, it's not very bright. It's disappointingly unbright. The distance horizontally is 5,421, but I'm going to round to 3 significant figures. And there we go. And the poor guys are going to be swimming in the river to get their food and medicine, which is going to be wet. Hey, maybe it was dehydrated food and it needed to, you know, just add water. So maybe they will be eating it in happiness. So there we go. That is how you solve motion in 2 dimensions, or let's call it projectile motion, free fall problems, where you've got horizontal and vertical motion together.